Hello and welcome to the Edexcel Further Maths videos for mechanics. This is impulse and momentum 2 and this is 2.1 momentum as a vector. If you remember from your previous work on impulse and momentum, when we have a collision we assume that there are no external forces acting and we think about the momentum depending on the mass and on the velocity. So we use this formula that momentum is the mass multiplied by the velocity. Momentum is a vector quantity and we measure it in Newton seconds. Another important thing that we think about with momentum is about the change in momentum, and we calculate this by subtracting the initial momentum from the final momentum. It's always important that you note on your work which direction is the positive direction. So we're going to start now with an example which is a recap of some previous work that you may have done. Remember, we've got here the direction vector I and it's pointing to the right, so that's the positive direction. So if we think about the initial momentum, remember it is the mass times the velocity, so it's 2 times 5I. Remember to underline your vectors. And then the final momentum, when it's moving away from the wall, is mass 2 multiplied by the final velocity, which is minus 3I. So our initial momentum is 10I and our final momentum is minus 6I. That means the change in momentum, using the formula from the previous slide, we have minus 6I minus 10I. So our total change in momentum is minus 16I. Now when we're working in 2D, we can work with vectors and we can write our vectors either in component form with I and J, or we can write them as column vectors. So we write it like this. If we are doing our momentum calculation, it's exactly the same, that it is the mass multiplied by the velocity, or we can do it as a common vector here. So once we've got our velocity, we can then work out our speed and direction. So our speed is the magnitude of our vector. If we think of our vector here, 3, 4, and so it's going 3 in this direction and 4 in this direction. So the magnitude is here, which means the speed is going to be the square root of 3 squared plus 4 squared. So we're going to have a speed of 5 meters per second. We also need to have a direction, and we measure the direction from the direction vector I. So it's going to be this angle here, and if you remember back to GCSE, that's tan of that angle is the opposite over the adjacent. So tan theta equals 4 over 3, which means the size of that angle is 53.1 degree. Okay, so here we have an example. We've got a ball of mass 0.5 kilograms moving with velocity 5I minus 4J. So it really helps if you sketch a diagram. Here we have our I and J directions. And if you look at this vector, we can see it's 5 minus 4J, so it's going to be heading down here. So if we draw in our right angled triangle again, so the speed is just the magnitude of the vector. So it is 5 squared plus minus 4 squared. You could just write 4 squared there because obviously 4 squared and minus 4 squared are the same because we're talking about the size of the vector. And we end up with a speed of 6.40 meters per second. Now if we want to look at the direction, what we need to think about is that we are going to be looking for an angle that is negative because it is below the axis. So we can do tan theta, which is going to be the opposite over the adjacent, so minus 4 over 5, which means that theta is going to be minus 38.7 degrees. It's often more useful to ignore the signs. Think of it as a right-angled triangle. And then from your sketch, this will tell us 38.7. And then from your sketch, you will know that because it is below the y-axis, we need to give the answer that the direction is minus 38.7 degrees. We can now find the momentum and the magnitude of the momentum. So if you remember that the momentum is the mass times the velocity, so this is going to be 0.5 times 5a minus 4j, or if we wrote that in column notation, that will be 2.5 and minus 2. And the magnitude of the momentum is just going to be the square root of 2.5 squared plus 2 squared, so it has magnitude 3.20, and that's to 3 significant figures. Thanks for watching Momentum as a Vector, and the next video in this series will be 2.2, the impulse momentum principle in vector form.